Okay, let's just take a look very quickly at what are radians. What are they, when do we use them, or why do we care? So, radians are quite simply just another unit for measuring angles. So, just like with weight or mass, you have kilograms and you also have pounds or stones. And with speed, you have meters per second, but you also have miles an hour or kilometers a light year or whatever. For angles, you have degrees or you have radians. There are a couple more as well, gradians and some other things like that, but we're only concerned with radians. So, why are we starting to use radians now? The reason we're starting to use radians now is because they are better. They are much, much better than degrees. It's a bit like how years and years ago, everyone used inches and pounds and other silly imperial units, but then every developed country moved on and started using meters and kilograms and things like that. So back when we were baby scientists, we used pounds and inches, and back when we were baby mathematicians, we used degrees. But now, if you're watching this, that means you have officially grown up in the world of mathematics, and we are using radians. So, what are radians? Well, fundamentally, radians are degrees that are based on circles. So, a circle, that's a circle, we should know has 360 degrees inside it. But 360 is a bit of an annoying number. In maths, and especially into higher end maths, 360 means nothing. It's just a random number we came up with. So what we do is we translate this into a number that is universally recognized in maths, which is pi. In order to compute radians, we need to understand the significance of pi. So all radians are measured in multiples of pi, essentially. It might be a silly multiple, might be a silly fraction, but fundamentally it is all to do with pi. The very, very core definition of radians is that in a circle, I can actually write this out, it's that important. In a circle, there are 2 pi radians. Or you can technically write 2 pi with a little c above for radians, but no one really does that. But technically you can. So in a circle, there are 2 pi radians, meaning, quite simply, that to convert from degrees, 360 degrees is equal to 2 pi radians. And this is the fundamentals of all of the angles we use in further maths and university maths and physics and science in general. At least I assume biologists have moved forward from the Stone Ages, but usually they haven't, so I'm not too sure. But in all of the proper advanced maths, engineering, physics, things like that, we use pi in radians instead of degrees. Okay, let's just have a look at a couple of very common examples. Generally, things to do with triangles, 180, 90, and 30 are often degrees that you will see within triangles or within trigonometric functions. So now, how do we convert that into radians? Well, remember the magic rule. And this is the one thing you need to remember if you're going to remember anything. 360 degrees is 2 pi radians. So 180 degrees is half of that, so it is pi radians. 90 degrees, half of that again, so it is pi over 2 radians. And then 30 degrees, well, it's a third of that, or it is 1/12 of that, so either 2 pi over 12, which is pi over 6, or 90 divided by 3, so pi over 2 divided by 3, which in both cases is pi over 6 radians. So we need to get used to seeing this, both in trigonometric functions, graphs, circles, basic angle calculations. We need to get used to seeing a lot of pi's popping up all over the place instead of these degrees. Okay, now let's have a look at some examples of where radians can make our life a little bit easier. So over here, I've got a very poorly drawn circle that took me far too long, well, longer than I'd like to admit to draw. I'm very happy about it, but imagine that's a perfect circle. And my goal is to find the length of this arc. So this red section here. And I've got my angle theta. Well, if we're working with degrees, hopefully we remember how to do this. We want to take the circumference of the circle, which is pi d, or pi 2r, and I want to find this section of it. And this is a fraction of the entire circumference. What's that fraction? Well, it is the same as the fraction of this angle over 360. So if I take that angle over 360, I get the fraction of the circumference that is drawn in red. So the angle over 360 times 2 pi r will give me my length of my red bit of my arc. So this is what? 2 pi theta r over 360. You've probably used this equation before, a little bit annoying. Let's instead do this with radians. So let's take my theta, and instead of it being out of 360, well, now it's going to be out of 2 pi. My 360 just changes straight to 2 pi. So now, in radians, I have 2 pi theta r over 2 pi. 2 and 2 cancel, pi and pi cancel, and the length of my arc is simply theta times the radius, which is a much simpler. So when we use radians, it not only looks a bit nicer and involves pi, but it also simplifies a lot of equations. Now let's have a look at another equation that this also simplifies. Okay, now I'm going to keep my same circle because I'm not redrawing that, even though it's rubbish. But this time, instead of looking for my arc length, I'm going to look for the area of this sector. Once again, in degrees, hopefully you remember how to do this. We once again want to take the fraction of the entire circle being taken up by this section and multiply it by the area of the entire circle. So the fraction theta over 360 applied to the entire circle will give me the area of this sector. So area of a circle is, of course, pi r squared. Now, if I do the same that I did last time, which is take my 360 and replace it with 2 pi, switching the entire thing into radians. So now my theta is measured in radians, my 360 is measured in radians. I have theta over 2 pi times pi r squared. Pi and pi cancel, and I am left with theta over 2 r squared, being the area of a sector within a circle using radians. Much simpler, much quicker to use. Radians are better.